All right. Let's see, why is it okay? Because n is bigger than 30. Bam! You can put chicken legs to me. Central limit theorem requires that to be true in order to know for sure that it's normal enough. That's why I can do anything on this problem. If I didn't have that, I couldn't do anything officially. That would be stats 2, which we don't teach. All right, so now look. Sample of 37, asking me a question about the sample mean. This standard deviation they give me is for individual infants. This question is about a group of shit. So I can't use that spread. I need the spread for groups of 37. So the very first thing I do is take what it was, divided by the square root of 37. What do you guys get? What do you guys get?
2.45.
Yeah. Is that right? 2.45. That is the spread for this problem now. Everything now becomes the same as always. I draw a picture, I put 80.2, there's 75, and I want less than 75. I make 75 into a z-score. My data point minus the mean, divided by the spread that works in this case. So that new step is getting the correct spread, the one that works for groups, not the one that works for individuals. That's all that first step is. And then none of the rest of the steps change. They're all the same. So make a z-score, look it up, get the area, adjust it if we need to. This one I don't need to, yay. What's that z-score there? Negative? 2.12? 212? Okay. So if you look that up, you get the answer. And nobody wants to look it up. Okay. What is it?
0.0170.
0170. Okay. Coolness. So like a less than 2% chance that a sample of 37 California infants will have a lifespan of less than 75. Good Lord. Which kind of makes sense. I mean, if the average is 80.2, and I take 37, and what's the probability they're going to live less than 75 years? That should be kind of small. The average is 80. I would expect it to be around 80. 75 is actually pretty far away. It's 2.5 steps. No, a little over 2 step. There you go, Jeff. Okay, maybe. So everything we did in that problem is exactly the same as we have been doing. Just the first step was new. Make the spread the right spread. This one, it's still just make these into z-scores, right? 81 minus, what was it, 80.2, divided by the new standard deviation. What do you guys get for that? Who did what? 0.33?
Yeah.
And then the z-score for 83. Then you look up those areas, you subtract them, right? That doesn't change at all. The only thing that changes is the spread. So how do you know when to do that? When I take a sample and I ask about the sample mean. That's when you know how to do that. What do you guys get here? I almost don't care anymore. To be honest, I don't mean that to be like it's just because that's the idea. The rest of it is just looking stuff up and subtract. Who cares? But what do you guys get anyway?
6293 for 32. Oh, not total.
I'm with you.
Not total.
I'm with you.
And then 8729 for 2936. 2937.
29? 24, yeah. Right? I like it. All right, and then the nastiest one on here, part D. Now, all right, to be really honest, if you're good up through C, and I know some of us are probably like, I don't know about good, but you start to see how this kind of comes together and when to do this. The very first day I told you, stuff in here is not that difficult unless you realize, okay, there's a bunch of Greek letters. There's concepts about when to change things. That's what's difficult, is keeping track about what in the problem tells me to use this versus do this versus something else. You got to realize what it is you're looking for a problem to say. You guys see that? All right. Part D is kind of like, I put this on here to lead into chapter 8, and we're not going to do chapter 8 until after the next test, but we can still do this right now. This is going to be exactly chapter 8, though, which I just kind of love to remind people that chapter 8 is not going to be anything new. Middle 95%, what the shit does that mean? Does everybody agree that's the middle? That's the middle 95%. So if I can find z-scores for those, I can convert them into x-scores with that backwards formula. So if that's 95%, how much is outside?
2.5 on each side.
Yeah, 2.5 on each side, because 5 total. So if I look up 0.025, you should get and if you look, now what should this be here? If that's the middle 95%, and a standard curve is symmetric around the middle, the other side's got to be positive 1.96. Holy shit. That's awesome. If you don't like that, what area is below this? 95 plus 2.5 is 97.5. If you look at 0.975, you get positive 1.96 done. Now I just got to make these into raw scores. Mean plus a sigma. So I get, where'd it go? 80.2 plus or minus. Is that okay if I do that? Right? 14.9 divided by, in fact, I'm not going to put 14.9. What goes in here?
2.45.
Yeah, 2.45. I was going to put 14.9 divided by square root, but we already know what it is. Why do I have to use 2.45 here? Because it's still talking about sample mean. And then I almost don't care. It's just plug in the calculator. 80.2 minus this, 80.2 plus this, looks to be about 75.2 and 80.
Wasn't it
70,
95% always two
something,
standard
I don't know.
deviations away? Isn't it supposed to be always 2 standard deviations away?
Yeah. And if you round 1.96, you get 2. So even that's kind of like a rounding. It was so close to 2, we made the rule 2 because that's easier to
I'm
remember.
just saying, like, couldn't you
Yeah.
just multiply?
You can't use 2 though because it is 1.96. Now that we have the z-score chart, we can be a little more precise. We don't have to round so much. We still have to round a little bit. Okay, let me give you the answer key for this. Yes? Definitely not. What do you mean? Oh, do you think it's the negative? It's equal, sorry. Yeah. Can't be negative, you're right.
No, I was asking if you can find it by just 2 standard deviations.
No, it's 1.96 standard deviations. See, that's what I mean. We can be more precise than just the rule, right? Here's the answer key for that practice test. We're going to make the formula sheets.
Yeah, I skipped around because I forgot how to do it. And this, we did something.
See again?
Yeah,
Could be, yeah. In fact, number 3 is sort of related to that. Not really. On the practice test. So guys, let's make the formula sheet, and then it's wide open to whatever. Today has been like a review of everything that's on the test. What's the test? Chapter 4, 5, 6, and 7. We're crazy, but those some of them have 2 sections, so shut up. Not that much.
Okay.
All right. So let's see what we got here. So chapter 4, it's basically the stuff that was on the quiz today, right? We got the all right, that's chapter 4, right? This out here. What up? All right. So this is the foremost from the quiz. That's chapter 4. Chapter 5. Has anyone done chapter 5 homework? There are 2 equations for uniform distributions. I actually use them on the practice test, but I am not going to put them on the test. They're the mean and standard deviation for a uniform distribution. Oh my God. I want you to know they exist. Why? Because every time we've encountered a new distribution, what's one of the first things we did? Well, how do I find the mean and standard deviation now? Because those are the 2 most important things for a quantitative data set, is those 2 things. I'm not going to use them though. They're kind of weird. Don't put this on your formula sheet. If you do, it doesn't matter. It's just going to screw you up. So it's up to you. But does this look familiar to anybody?
Yeah.
All right. And the question I love is people say, why 12? I love that question because it's like, why any of it? To be honest. So I actually have the proof typed up, and I'm not going to give that away. If you're curious, you can email me or come by. I have the proof of it. It involves, it involves some calculus. So if you just want to look at it and go, oh, that's fine. But that's the standard deviation for a uniform distribution where B is the highest and A is the smallest, right? So if it said from 7 to 15, it'd be 15 minus 7 squared divided by 12 square root to get the standard deviation. I want you to realize there's always a way to find the mean and standard deviation for some situation. This isn't really used a ton of times. So that's why I'm not generally worried about it, but I want you to know they exist. Okay, so screw that. So chapter 5, there's nothing. There's no formulas. It's make a box, get the height, draw a box, get the area, right? For chapter 5. No formulas that I'm going to let you write down. Chapter 6, you got this business. You can even write this business here. You got this business here. Just to sort of trip your mind, you can even write this down. People always get worried or freaked out about that. Why do I have to change this? Because that's for individuals, that's for groups. If I give you S, what does S mean? Of a sample. It's still for individuals. I would still have to make it for groups if I did take a group and ask about the sample mean. Okay. Let me think. Anything else? Oh, get out of here. You got this guy you can put back down here if you want to. Well, if I were you, I'd do it. Right? We used that one already a few times today, so it's probably going to be important. Anything else that I might have forgotten? Feels like I forgot something, but I don't think I did. No, that's everything. Yes?
I think there was a formula about like finding the percentile in chapter 5.
Yeah, sort of, but I'm not gonna worry about that. The formula is actually kind of silly when you realize for a uniform curve, a percentile is very simple to find. It's just to go up so much percent above whatever the minimum is, so if they had a little formula for that, I don't care. I'm not gonna really ask a question for that, so you're okay there. Anything else? Any other suggestions? What should be up there? Yes?
Like the probability of A and B equals probability of
No. No, so the chapter 3 will not be on this test directly. Sort of indirectly with the or and the and, meaning addition, multiplication. But you can bring them, you can bring all your formula sheets, always, any test. But you're not gonna need the probability formulas. They're not gonna be on here. It's chapter 4 through 7. I gave chapter 3 its own little double quiz. It's had it plenty. They'll show up again on the final. Yay. Okay. Everybody got an answer key right? Oh. So now you guys, whatever you want to ask about, or if you don't want to do anything, you can. No, the way quizzes work is if you miss it, then grade on your test takes the place of it. You need your, yeah.
And whatever, yeah.
Anybody else not get their double quiz back? Oh, Paris. Paris.
You know how we do for chapter 1 and 3 as well? Like, one example, can you accept all?
Day of the fun. Homework corrections due the day of the fun.
Homework?
Anytime up until day of the fun. No, homework corrections.
Homework.
Do the day of the fun.
Got it.
Quiz and test corrections due the day of the next test.
Got it. So the next test is
Tomorrow.
Got it.
Yeah. Oh,
I have enough time. And then, you want me to just email you about that quiz? Or is there a certain day that...
oh, the double quiz, right? The probability quiz? Oh, yeah, yeah. Email me. All right. Everybody wants you to just leave? Anybody want to ask questions? Everybody just wants to leave. All
Can you
right.
look at the test questions through the back?
Which test are you have? Oh, shit. Did I bring them with me? Oh, I think I left my... Yeah, I left my test answer key upstairs.
Should I just bring it in tomorrow?
Sure.
And then you look at it right before you
Yes.
Okay, thank you.
Thank you. Put all this stuff in. They all disappeared. Oh, this is them. Okay. What's up? You guys are...
We just want to say, can we take it Friday then for the final?
7:30 a.m. on Friday.
I don't know what time the assessment office opens. I don't think they're open at 7:30. You see what I'm saying?
Yeah.
Well, all right. That doesn't matter because that's when I'm giving the final. So if you guys come at 7:30, let me see. You're gonna have to remind me a few times, and then I could come to this room at 7:30 and get you guys started in the final. And when people come in, I might have to put you outside or somewhere because they're gonna have questions. Does that make sense?
Yeah.
And you just kind of keep working.
Okay,
Yeah.
thank you.
Just remind me a few times.
Okay, real quick, how would I describe it? They are dependent because, how would you want to describe it?
Well, what's that probability? That's the probability of sprint, right? That's probably sprint.
Yes,
That is the probability of sprints given female.
yes.
Because the check to see if A and B are independent is if probability of A equals probability of A given B, they are independent. But you found that the probability of S does not equal the probability of S given F, so therefore they are equal.
I have a question. So, like you said, start from